Hey everyone! So in this video we're talking about some of the equations that are not easily factorizable using I power like what we did in the previous two videos. So let's say we have the equation y equals to x squared minus 4x plus 2. Now clearly you can't really factorize it by I power, right? You know, the common integral or integer factors of 2, well, none of them will add up to minus 4 or give you a combination that gives you minus 4. So what can we do from this? Well, the first step when it comes to dealing with these types of equations where you cannot easily factorize is to always check whether or not there are real roots or not. And we bring the idea of the discriminant, where if we have b squared minus 4ac is bigger than or equals to 0, we have real roots. Whether is it distinct or repeated wouldn't matter. On the other hand, if we have b squared minus 4ac giving us a negative number, then there are no real roots at all. Alright, so keep that in mind when you're doing the type of quadratic equations where you cannot easily factorize them. So let's use the discriminant to tell us whether or not there are real roots or not. Alright, so because if one of them has no real roots, then it will be slightly easier to sketch it because you just need to consider the y-intercept and the turning point of the quadratic graph. Alright, so in this case, if you take a look at b squared minus 4ac, it's gonna be minus 4 squared, so I get 16. So let me use a different color. So I get minus 4 squared minus 4a is 1, so I'm gonna leave it as 1, then ac is 2. This will then be 16 minus 8 to give us 8, which is bigger than or equals to 0. So you know that there are real roots, and because it is bigger than 0, it is two distinct real roots. As such, the graph will look something like this. Alright, somewhere around there. Alright, so you intersect the x-axis at two possible points, so something to keep in mind. Alright, so now let's find the roots. So using the quadratic formula, we let y equals to 0, we then have x equals to, I'm going to skip writing the entire equation again, so if x equals to minus b, so we have minus 4 plus minus, because quadratic equations usually gives us two roots, so therefore we need the plus minus b squared minus 4ac, which we found out to be 8 over 2a, so 2 times 1, 2. This then gives us 2 plus minus root 2. Alright, because 8 is basically 4 times 2, so 2 root 2. Alright, so those are our roots. So we have 2 plus root 2 and 2 minus root 2. So if you know the value of root 2 is basically 1.4 something, if I'm not mistaken, and it's gonna be positive. Alright, so we are gonna know that both roots are gonna lie on the positive x-axis side. Therefore, we're gonna draw this graph. Okay, that's a terribly drawn one. Let me try that again. Okay, here we go. Looks slightly better. Alright, so this is our graph, y equals to x squared minus 4x plus 2. The roots are, of course, y we have 2 plus root 2 will be bigger than 2 minus root 2. Alright, so we can then label the points 2 minus root 2, comma 0, and 2 plus root 2, comma 0. Now at x equals to 0, to find our y-intercept, it will simply be the constant, so we get 0, 2. Now the turning point will occur again at the midpoint between 2 minus root 2 and 2 plus root 2. So it is simply 2 plus root 2 minus, plus 2 minus root 2 whole thing over 2. So it will occur at x equals to 1. Alright, so at x equals to 1, we have 1 minus 4 plus 2 minus 1. Alright, so here turning point is 1 minus 1. Alright, so that will be the graph of using the quadratic formula if there are two real roots. Of course, I left out the negative coefficient of x squared, but it wouldn't make a difference. Alright, it would simply be the same shape, just that it's now in the n shape, and the logic is pretty much the same. Whether or not there are two real roots, you get an n shape that will intersect the x-axis twice if the b squared minus 4ac is bigger than 0, or if, let's say, b squared minus 4ac is less than 0, then it wouldn't intersect the x-axis at all, and it would therefore be below the x-axis. Of course, if b squared minus 4ac equals to 0, then there will be one repeated root which basically is the turning point. All right, so that is the quadratic formula. In the next video, we're looking at what happens if we can't use factorization and there are no real roots. What happens then? Stay tuned.